bubble sort we discussed, and we have to write the algorithm for the bubble sort as well. And I mentioned one more sorting algorithm as a quick sort, but I thought to discuss merge sort because quick sort is a bit difficult to understand with compared to the merge sort. Then as the second sorting algorithm, I decided to discuss merge sort, right? We have few more couple of sorting algorithms. From that, for this course, we discussed two sorting algorithms, bubble sort and merge sort, right? Bubble sort completed by yesterday. So today we are going to discuss merge sort first, right? Merge sort means uh, let's assume you have an array with numbers, and again your task is to sort them in ascending order, right? In bubble sort, what we does is taking two numbers at a time and compare them. If a number or the second number is greater than with compared to the first number, uh, we can place as it is. But in other words, another way, the second number is less than with compared to the first number, we can swap them, right? Likewise, we can continue up to the last element of the array, and we can finish the first set of iterations. Then we can move to the second set of iterations, and at the second time, we have to move up to the just before index or the n minus 1 index, right? It is bubble sort. Merge sort means first we are going to split our array into single elements, right? First we have an array. Let's say we have an array with index number 10, right? We have an array with 10 numbers, right? Then we are splitting them into 10 single values, 10 single memory slots. After that, we are going to merge step by step, and at the merge state, we are going to rearrange this element in ascending order. Let's see an example, then you can understand what is mean by merge sort, right? Okay, I'm taking, let's say, 8 numbers. All the numbers are stored inside an array. Right. 8 indexes are there. Let's say the array name is A. Then it is having these numbers 3, 7, 8, 5, 4, 2, 6, 1. Right? These are the given numbers for this scenario. Right? 4, 6, 1. Right? This is 1. We call this edge as lower boundary, this edge as upper boundary. Same name, same both names are used in quicksort as well, right? Here also in the merge sort, we are using these two words, lower boundary and upper boundary. Then as the first step, we have to find out the middle of this array, middle index of this array. First, I'm using these index numbers 3, 2, 2, 3, 4, 5, 6, 7. Totally 8 indexes are there, and the actual index numbers are starting from 0 to 7. Totally, we are having 8 indexes, right? 8 memory slots for this array. Then we have to find out the middle position of this array. This is the algorithm. We can add first index with the last index. then divide by 2. As the result for this calculation, we will get 3.5. But in this scenario, we are only considering this integer part. We just remove this decimal point and we are considering this integer part only. Right? 3 means this is the middle of this array. Middle part of this array. Right? Then we are splitting this array into 2 different arrays. We are taking this part separately, this part separate. 4 indexes are there in the first half of this array, and another 4 indexes or the numbers are there in the second half of this array. 3, 7, 8, 5, 4, 2, 6, 1. Right? Again, we can repeat the same steps. For the first half of this array, this is the middle section, middle point. For the second half of this array, this is the another middle section, middle position, right? Then again, based on this middle of this array, we can divide this array into another 2 different arrays. 3 and 7 is there, 8 and 5, 4 and 2, then 6 and 1, right? Then again, we can divide these numbers further, or we can divide this array indexes further. 3, 7, 8, 5, then 4, 2, 6, 1. Now we splitted our array with 8 index into 8 single values, right? 8 single different values, right? Memory slots, right? Now the splitting part is completed. Now we are going to merge them, and at the merge stage, we can sort them, right? Now the first half of this algorithm is completed. Then as the second step, we can merge them, right? For the merge step, we have to define 2 different pointers, right? 2 different pointers or 2 different arrays, right? For this one, for the first set of numbers, I define 2 pointers I and j here, and we are going to merge these 2 indexes into a single array, right? And at the insertion part, we have to take the numbers one by one. For this I pointer, I'm taking number 3. For the j pointer, I'm taking number 7. Then we can compare I with j, right? We can compare these numbers using if condition, let's say, right? We can compare this I greater than or equal to j. If this gives true, it means the first number is larger with compared to the second number. If this gives false, it means the first number is less with compared to the second number. By just looking at these 2 numbers, we can say number 3 is less than with compared to number 7. Then we can place 3 first, then 7 second as the second element. Then we can take these 2 numbers, these 2 indexes. Again, we are going to place these 2 numbers inside a single array, right? Again, we can define 2 different pointers, I and j. Then we can compare, or we can temporarily copy these numbers into I pointer and into j pointer. Then we can compare them. Again, we can ask this question, I greater than or equal to j. This time it gives true. Why? The first element is greater with compared to the second element. Then we can sub them. Sub them means we can insert number 5 first, number 8 as the second element. Then we can take another two numbers or the next two numbers and we can place them inside a single array. Again, we have to define, or we can use the same pointer in each location, right? I and j. This time again, I greater than with compared to j. Then we can place number 2 as the first element and the number 4 as the second element. Then we can take last two numbers. Then again I, j. Again we can ask the question, I greater than or equal to j. If I greater than or equal to j, we can sub them. 1, 6. Now the first part of this algorithm is completed and every single array is now sorted. Right? You can see all the less numbers are at the left side and the larger numbers are at the right side of these arrays. Then we can take these two arrays into a single. Now we are having 4 index array. Again, we can define two pointers I and j. Now I should be in the first array, j should be in the second array. Then we can take one number from the first half of this array and one number from the second half of this array. Then I gets 3, j gets 5. Then we can ask the same question, I greater than or equal to j. This time it gives false. It means the first number is less with compared to second number. Then we can insert 3 as the first element of this array, of the new array. Then we can move this I pointer into second index. For the second array, we are not moving j because we are not taking any number. Still, we are not taking any number from the second array. Therefore, we are not moving this j into the next step. Then we can move I into the second pointer. Now, what is the updated value for the I? It's 7, right? Then we can compare 7 with 5. What is the smallest number? 5. Then we can insert number 5 as the second element of the new array. Now, we can move j into this next index. Now, I is having 7, j is having 8. Then we can ask the same question, I greater than or equal to j. This time it gives false because number 7 is less with compared to 8. Then we can insert number 7. Then we can check whether further items are available or not in this array. Now it is an empty one. It means we are just came to the end of this array. Then we are not moving this I further. Then j now is here. Then we can take the last number to the new array. Now the first two arrays are sorted and stored inside a single array with 8 indexes. Now we are taking the second two arrays and we are merging them into a single 4 index array. Again, I and j. Then we can compare them. This time j is less with compared to I. Then we can place number 1 here. Then we can move j further. Still I is there. I is at the first index of this array. Then we can compare 6 with 2. This time 2 less. Then we can place 2 here. Then we can move I in the forward direction. Then j is having 6, I is having 4. Then we can compare them. This time 4 is less with compared to 6. Then we can place 4 here. Then 6 here, right? As the result from this step, we are having two different arrays with 4 elements each, right? Then we can further uh, merge them. Again, we can define two pointers I and j. Then we can compare them. I is having 3, j is having 1. What is the smallest one? 1. 1 means j. This is our final array for this data set. Then this time I is the smallest one with compared to 3. Then we can place 1 here. Then we can move j into the second index. Still I is at the first index of this first half of this array. Then I is having 3, j is having 2. With compared to them, 2 is the smallest one. Again, we can move j further. Now I is having 3, j is having 4. With compare them, 3 is the smallest one. Then we can place 3 here. Then we can move j into forward direction. Then with compare to 4 and 5, 4 is the smallest one. Then we can move j pointer into the next element of the second half of this array. Then 5, 6, 5 is the smallest one. Then we can place 5 as the next element. Then we can move here. Then 6 and 7. 6 is the smallest one. Then we can place 6 here. Then we can move forward, but we are not having any element here further. Then we can stop moving j. Then we can place the last value which is having I. We can place it in the next element 7 and 8. Now the array is sorted. Right? This is the merge sorting algorithm. Merge sorting algorithm, right? First, we are taking the array and based on the middle position, middle index, we split array into two different parts. And following the same steps, we can split the entire array into up to we can get the single index elements. Up to this point, we are splitting our original array into smallest part. Then we can merge them, and at the merge time, we can compare these two numbers, and based on the value, we can sub them, or we can place in the smallest number in the left side and the largest number in the right side. And we can further merge step by step, and at the end, we are having the well merged, well sorted array for the given numbers. Then what is the time complexity for this algorithm? We can say it is big O n log n. Time complexity for this algorithm is big O n log n. For the bubble sort, what is the time complexity? It is n squared, right? Time complexity for the bubble sort, it is big O n squared. Time complexity for the merge sort, it is big O n log n. With compared to the time taken for this sorting process, merge sort will get less time with compared to bubble sort, right? This is the basic idea of bubble sort and merge sort. Then if you have any questions up to now, you can place in the chat. Or if you need any need a note, you can take it by taking just 5 minutes. After the 5 minutes, we can implement the pseudocode, so algorithms for both merge sort and bubble sort algorithms. If you have any questions up to now, you can just unmute your mic and ask, or you can put your question in the chat section as well. I will share this recording with you by considering the current situation or the weather condition. I decided to share this recording with you through your LMS course page. Therefore, you can go through this video again, right? Right. Once the element gets odd number, it is not an issue because we are only considering the integer part. Let's say you are having 9 elements. 9 means, let's say this is your array. One, two, three, four, five. Indexes are starting from 1 to 8, right? Now, if you want to find out the middle part of this array, 0 plus 8 divided by 2, you will get 4. Then this is the middle of this array, right? We are taking this part as the first half of this array and this part second half of this array, right? For this scenario, it gets 5 elements for the first half, 4 elements for the second half. It is okay, right? It's totally fine. We can continue the same algorithm for this part as well, right? Okay, we will discuss one more example with odd numbers. Uh, some students are asking about the time complexity calculation. For the bubble sort, it is simple. As I showed in yesterday lecture, uh, let's say you're having 5 elements, it gets 1, 2, 3, 4 set of iterations, right? Then if it is n number of steps or n number of elements, it gets 1, 2, 3 up to n minus 1. Then by considering this series, by the total time taken for this or the total number of iterations, you can calculate it by adding n times n minus 1 over 2. It means this gets big O n squared, right? But merge sort, it's a bit complicated to, or in your level, we are not discussing how to calculate this time complexities. Just you have to know about this. And by just looking at these numbers, can compare them. N squared means it gets, if you draw a diagram or a graph for n squared, it's something like this, right? For log n graph, it gets something like this, right? Then by comparing these two, merge sort will get less time with compared to bubble sort. This is the point only you want to know up to this point, this level. Then in your third year, you have another course named as Design and Analysis of Algorithms. I think the course code is 3152 or something. From that course, you can learn how to calculate these time complexities, right? How to calculate these time complexities, you can learn it from your next year. We are following CSC 3152. Up to this level, we are not discussing how to calculate, but to clarify or to show how gets these numbers. That is the reason why I showed you how to calculate the time complexity for bubble sort. It is very simple. By following these simple steps, we can calculate the time complexity. This is bit complicated, right? A bit complicated. Therefore, we are not discussing about the time complexity calculation for merge sort. Any more questions? No. Let's discuss one more example with odd numbers of items. Right. It's assume you are having an array with size 7. 1, 2, 3, 4, 5, 6, 7. Again, I'm using the same set of numbers, right? 3, 7, 2, 1, 4, 5, 6, right? Now we are having 7 different numbers. Indexes are 0, 1, 2, 3, 4, 5, 6. Then if you calculate the middle of this array, 0 plus 6 divided by 2, it gives 3. 3 means this is the middle of this array, center of this array, right? Then we can split them into 2 different arrays. This time, the first half of the array is gets 4 elements. Second half of this array will get 3 elements. Then this is the middle part. This is the middle of this array. Then we can divide further. 3, 7, 2, 1. 4, 5, then 6. For the last array, we are not further splitting because we are having only one element for this array. Therefore, not further splitting them. We can keep this number 6 as this. Then we can split further 3, 7, 2, 1, 4, 5, and 6. Right? Then we can use 2 pointers I and j. Now splitting part is completed. Now we can merge them. This time I is less with compared to j. Therefore we can place 3 here and 7 here. Then this time 1 and 2. This time 4 and 5. Still number 6 we can keep aside. And as the next step, yes, 4, 5 and 6, right? 4, 5 and 6. We can keep first 2 numbers inside a single array. We can keep the last one, number 6, inside another array, right? Then we can use these two. Right. When we calculate the middle of this array, this one, how we calculate? 0 plus 2 divided by 2, it gives 1. 1 means this is the middle part of this array. Then we are taking first half separately, second half separately, right? Right. 3712. Then we can merge all four inside the single. I and J. With compare I and J, this time J gets smallest one. Then we can place 1 here. Then we can further move with compare with J and I, this time again J gets smallest one. No further items, we can place 3 here. Then we can place 7 here. For this, we can take this array and this single index array. I is there, J is there. Now we are having 3 elements, I and J is having 6, I is having 4. Then we can place I or the number 4 as the first element. Then we can move further 4, 5 with compared to 6, 5 gets smallest one. No more elements, then we can place 6 here. Then we can further merge these two arrays into a single one. Right? I, J, number 1, move forward. Number 2, move forward. Number 3, move forward. Number 4, move forward. 5, move forward. 6, no more elements. Then we can place 7 here. Now the array is sorted. Right? This is what happens when you are having odd number of items. Right? Even numbers or odd numbers, we can directly, we can without any issues, we can use merge sort algorithm. Right? I hope you got the idea. Then if you are if you are having any doubt, you can place your questions in the chat, or you can just unmute your mic and ask any question. Then if you need a note, you can take this. Right, shall we move to the coding? Before that, we have to write the algorithm for both of them, right? For the bubble sort, what are the steps? For the bubble sort algorithm, what are the steps we have to follow? That's the first step. We can search, check if the first element in the input array is greater than when compared to the next element in the array, right? It is the first step. First, you can check if the first element of the array is greater right? This is the first step. As the first step, you can check whether the first element of the array is greater than with compared to the next element of the array. And as the next step, you can say if it is greater, swap them, swap them, or swap the two elements. 。
elements. 。 。 。 。 。 。 。 . 。 。 . 。 。 . 。 。 . 。 。 。 。 。 . 。 。 。 。 。 。 . 。 。 . 。 。 . 。
。 . 。 . 。 . 。
。 . 。
Otherwise, you can move forward, right? Move the pointer forward in the array, right? Then as this third step, you can repeat first two steps again. First two steps until we reach the end of the array, right? Then as the final step, you can check if the elements are sorted. Then not, you can repeat the same steps. If not, repeat the same steps or same process until the entire array is sorted, right? This is the key steps for bubble sort. First, you can check the first element with the second element of the array. Then the if it is greater with compared to the second element, you can sub them. If not, you can keep them as it is. Then you can move to the next point, or you can move your pointer to the forward direction. Then again, you can repeat the same steps, same first and second steps. And at the end of the set of steps, you can check whether the elements are sorted or not. If still it is not sorted, then you can repeat the same process again. First, second, and third steps, right? This is the algorithm for what? Bubble sort. How can you find out the termination condition? What is the point of the termination of this algorithm? Yes? What is the termination? How you can find out the last iteration of this algorithm or this process? Yes? We can say the first step, the termination condition, right? This is very important. Termination condition. What is the termination condition? The algorithm stops when a full pass is completed without any steps. It means it indicates or it says uh, the given set of data or given set of indexes are fully sorted. This is the termination condition. It's very important. When you are implementing an algorithm for this, this is very important, right? Then we can move to the merge sort. Merge sort. It is, we are using another name for this kind of algorithms, merge sort type kind of algorithms, divide and conquer. Divide and conquer means first divide the given or we split the given data set and then we can recursively merge them. Right? First, we divide the given data set or given array. Then recursively we can merge them. We call this as divide and conquer. Divide and conquer algorithm. Right? Another example for divide and conquer algorithm is quicksort. In the quicksort, also we are splitting the original array into smallest units, and then uh, by taking the components one by one, we can merge them and we can sort them, right? Okay, for the merge sort, what is the algorithm? What's the first step? We can split uh, the unsorted array into half at the midpoint, right? Then as the second step, we can recursively call merge sort, or we can recursively merge them, or we can recursively merge both halves until each subarray contains only a single element, right? Recursively call merge sort on both halves until each subarray contains only a single element, right? Then for the third step, we can combine them. Merge the two sorted halves back into a sorted single sorted array by comparing their elements one by one, right? This is the algorithm for merge sort. If you want, you can take a note here. This is the algorithm for merge sort. Right. Then I will show you how to convert an algorithm into actual coding. I'm taking a linked list example for this. Hope you can remember the steps, how to insert very first element or very first node into a linked list, how to insert uh, a node into a middle position of the linked list, how to insert uh, a node in the the first element or the last element of the array, linked list, Then how to delete, I hope you can remember the steps. Therefore, I'm not taking too much time to explain these steps again and again. Just to recap or remind, let's say for the empty one, head and tail both are having null condition. Once you initialize an empty linked list, both pointers are having null, right? Both pointers are having null condition, right? Then for when you are inserting very first element, very first node to this array, sorry, linked list, first you can insert or we can distribute the required data inside the given section of the node. Then we can initialize this pointer as null. What is the reason for initialize this pointer as null? In some cases, these pointers are having garbage values. To remove them, just simply we can null them, right? Then head and tail both are still having null. Then we can create a link between head and the new node first. We can give the memory address of the new node inside the head. This is the first step. Then we can give the same memory address into the tail pointer as well, because still we are having only one node. This is the second step. Okay, let's try to implement this as a code. Here I'm using Eclipse IDE for the Java implementation. You can use any kind of editor for Java, C, Python, whatever the things you want, you can use any kind of any kind of editor here. Uh, right. What one to right. Launch. How can I change these colors? I don't know. Colors and fonts. Hopefully we can try with these colors. If you can't see these characters clearly, please let me know, right? This is a dark color background. I think this is not perfectly working for this. We'll try. Right. Okay, a project is initialized. Then we can create a class for this. New class. Then name for the class, let's say linked list. Can you see these letters? Can you see these letters? Are they visible on your screen? Okay, thank you. So, right, this is the linked list class I'm going to use for this implementation. Can I place another class inside this class? This is, you can answer for this question from your first year, second semester knowledge. Is it possible to place another class inside this? Yes or no? Can I place one class inside another class in Java? Yes or no? No answers. We can place another class inside this, right? If you want, you can use, let's say, uh, simply you can say class node. One class, another one a class inside another class. We can place it, right? Then how many variables are needed for node class? I'm going to design my node here, right? Here I'm going to design my node. My task is to store one integer, right? My task is to store one integer here. That's it. Then how many variables are needed for this node class? Yes, I need your answers. Now you have completed all of these discussions in your lab sessions. Therefore, I need your answers. How many variables are needed to implement or design the node of this scenario or a node for my linked list? One section needed for store data, another section needed for store the yes two. Another section needed for store the next pointer or the memory address of the next node, right? Then we can say int data. Then we can say node next. In Java, we are just choosing this memory or the object references. In C, we are working with memory addresses, right? Therefore, the C language is the most suitable programming language for learning data structures. Right? In Java, we are just creating some objects for nodes, for linked list, for these next pointers, and just taking the references of that objects, right? It's not showing the actual meaning of these data structures and memory handling, right? But unfortunately, in the university or in your lab sessions, it is designed to work with Java, right? I don't know what is the reason for that. Inside this node class, we can create the constructor for this public node. Then as the parameters, we can take the data here, int data. And inside that, we can initialize these two variables. This dot data equals data, and this dot next equals null. What I just here is in my algorithm or the steps, as I mentioned earlier, first you can initialize an empty node, right? By just calling the constructor of the linked list class, we can initialize an empty object for this node. Then we can distribute data here. That is what happened from this code line. Can distribute this passing data inside this location. And initially we are not having any pointer or the memory address or object reference for the next one, next node of the linked list. We are just initialize a node, right? Therefore, I can null them, or I can initialize this next pointer as null. That's it, right? Then this is the story, or this is the content needed for class, sorry, node class, right? Once I create an object from this class, node class, it creates this. It creates this one, right? Right. The entire linked list is a different story. Then the entire linked list will be belongs to this class. Then we can create the head pointer, head and tail pointer inside the linked list class, outside the node class. Right? Inside the linked list class, outside the node class. Because for the node class, it is not necessary to having a head. Right? Head is needed for linked list. Therefore, I can create node type head. Why? Why node type head? Why node type head? Here, the node type next means you are going to store an object reference inside this variable, and the next node is already a node type, right? Using the same class, we are using the same node class, we are creating multiple nodes. Then the object reference are in node type. That is the reason for this next pointer is having node type, right? Then here, the head pointer, it's again having node type. Why? Here, by just looking at this diagram, you can see inside this head pointer, it stores a node type object reference. That is the reason, right? We are storing node type object reference here inside this head variable, right? Head pointer. In C or in actual programming, we are seeing using the word pointer. Inside the head pointer, we are storing node type object reference. That is the reason for this head variable is having node type, right? Then again, we can use the constructor here, public linked list, and initially we can initialize this head pointer as null, right? Then inside your main method, you can uh, create or initialize an empty linked list using this constructor, right? Simply just using this linked list constructor, you can initialize an empty uh, linked list having only a pointer, and pointer is initialized with null, right? Let's say linked list, list one, a name, new linked list, right? That's it. Once I run this code, what happened? It calls this constructor and initialize an empty linked list, and it is having one pointer or head pointer, and it is initialized to null. Then we can implement the insert function. Let's say public void insert. When I try to insert one item to the linked list, we have to initialize an empty node, and we can distribute the data. For the respective data part, I can pass it as an argument for this function. Then using this node class and this node constructor, I can initialize a node and is having the data part, and also by just calling this node constructor, we can initialize this next pointer as null. Inside the node insert function, we can say node new node equals new node. Then we can pass data here. Because for the constructor, we have to pass one data element, one argument here. We can pass the same variable inside the node constructor. Then as the first step, to insert one very first node or any node, you have to consider two scenarios. First, you have to check whether the linked list is an empty one or not. Not means it is uh, already having a node or not. Just we can use an if condition, and with if condition I can compare, or I can check the value inside the head variable. If head equals null, what it means? Null means an empty one. We can just simply assign the new node reference into the head. That's it. That is what happened here. See, initially head is null, tail is null. This for this code example, I'm not using a tail pointer. If you want, I can use it. Initially head is null, and we are having an empty or uninitialized node with its own data part. That is what happened when I execute this code line. After that, I have to combine, or I have to join this new node with the head. Then I can connect this, so I can create this link between head and node here. That is what happened in this if block. First, I can check whether head is null or not. If it is not, if it is null means the linked list is already an empty one. Then I can assign the reference of this node object into the head pointer. If not, or just we can return from the function at the end. If not, if not means you have to find out a location, right? If you, or let's say You're going to insert your new node as the very first node, and this time the linked list is having one node, right? I just means that you're going to insert another node into the same linked list, but this time the linked list is having one node. It is no longer an empty one, right? It's no longer an empty one. You're going to insert the new node as the first node for the linked list, right? Now this linked list is having only one node as the very first one. Head is initialized with the reference from the first node, currently first node, right? This is my new node. When I break this connection, as the first step, you will be lost the existing nodes in the linked list. Therefore, first you have to make a connection between this and this. You can update the next pointer of the new node with the existing first node. This is the first step. Then as the second step, you can create a link between head and new node. This is the second step. After the second step, you will break this connection. Then you can combine or you can connect the new node as the first node of this linked list. Let's try to implement this in code. Right. Else. Else means your linked list is no longer an empty one. Then first you have to make a connection between new node and the existing node, right? New node and the existing node. Before that, yes, I can remove the else part from here because here I'm using a return condition. Then once a node is inserted, just return from this function. Without using the else phrase, I'm creating a temporary variable temp and store the reference already stored inside the head variable, right? Then I can update uh, the new node next pointer of the new node with the uh, value stored already inside the head variable. It means currently before connecting the new node into the linked list, the reference of, of the existing first node is stored inside the head variable. Then I can use that and store it inside the next pointer, right? Then I just created this connection, the first connection. Now it's completed. Now I can update the head with the new node. It means what it means. It creates the second connection. Now the first connection is cancelled out and the second connection is created between head and new node, right? This is insert front. Let's see, insert front. If you want to insert a node as the back element or the last element of the linked list, I can implement another function for that. Insert public void insert back. Again, I can take data part, and same as the previous one, I can create node, a new node from the node class, and I can distribute the data here. And if you want to insert a new node as the last element of the linked list, first you have to traverse through this linked list. Before that, you have to check whether the head is null or not. If it is null, you can just simply insert the new node as the first node, because we are not having any nodes at the very first one, as the very first one. Then if you want to add the next one as the last element of this linked list, first you have to traverse through this linked list from head to tail, or head to the last one, right? After find out the last node, first you can update this null pointer of the previously last node with the new one as the first step, right? Then if you have a tail pointer, you can update the tail pointer with the new node as well, right? Then this is by default assign null for the next point of the new node, right? Just you can simply create a link between previously last node with the new node. Okay, let's try to implement this. First, you have to check whether your linked list is null or not, or empty or not. You can simply use an if condition. If head equals null, then if it is null, it means an empty linked list. Then you can update the head with new node, and you can return from the function. You can return from the function, right? If not, again, you have to create a temporary variable and store the very first object reference from the head of the linked list. Then using this temporary variable, you can traverse through your linked list from head to tail. You can traverse through this linked list from head to tail using a while loop. While this 10 is not equals null, right? Not equals null means when you just came to the end of this linked list, the next pointer will get null, right? You can use this condition, this scenario for the termination condition for this while loop. Then I can traverse through this linked list one by one by updating temporary variable temp dot next. Once the while loop is terminated, it means you just came to the end of this linked list. Then you can use temp dot next equals new node, right? From this function, insert back function, you can insert your node as the last element of the array. Sorry, last element of the linked list, right? Hope you got the idea. Here, this is a simple logic. For insert as the back or the last element of the linked list, first you have to check whether the linked list is empty or not. If it is empty, you can update the head pointer directly with the new node. If it is not empty, you have to traverse through this linked list from starting points to the end point, or head to tail of the linked list. Therefore, I'm creating a temp variable and pointed it to the first one. As the first step, we can place it to pointed it to the first element of the linked list. Right? I can take the object reference of the first node from the head variable. Then using this while loop, I can traverse through this linked list by checking the value inside the temp. Temp null means you just came to the currently in last element of the linked list, because we are updating the temp variable with the next pointer of the current node. Next pointer of the current node, right? If you just came to this node and execute this code line, it taken the next pointer reference value of the current node and store inside the temp. Currently, it is having null. Again, if you want to execute this while loop, again it checks the value inside the temp variable. Now it is null. Then the condition is unsatisfied. Then terminate this while loop. Now the temp variable is pointed to the current last node. Temp variable is pointed to the current last node, right? Then I can say I can access to the next pointer of the current last node by just using temp.next. Temp.next. Then I can assign the object reference of the new node inside the next pointer. It means you are going to create a new link between this and this. That's it, right? When you execute, or when you insert, when you call this function, it inserted your node to the last element as the last element of the linked list. This is for insert front. This is for insert back. Then if you want to insert your new node as the middle element, middle node of your linked list, then you have to check uh, the location by traverse through the linked list, again a while loop, using a while loop. Inside the while loop, you can use another if condition. Just I can implement the function quickly. Public void insert mid. Again, I can take the data, and this time I just wanted to know the location. Location is gives by with another number, right? Let's say, for an example, you are having this linked list. Head pointer, it's pointed to the currently first one. Let's say you are having these numbers. You're having these numbers. Then if you want to insert your new node after the second node, or the node is having number 5, you're going to insert this new node in this location, right? First, you have to find out this location first. You can use these numbers, right? You can use these numbers, or you can use the index numbers as well. You can initialize an index for this linked list. Is a different story. For this, you can use these numbers, stored numbers in each and every node. Then if you find out the location, first you have to create a link between new node and the node 3. This is the first step. Then you can break this connection by just creating a link between target node and the new node. This is the second step, right? Your first task is to find out the target location. right? As this parameter, I can pass this location. In this example, I can use number 5 as the location or the uh, position you want to insert your new node. Right. Here I want to create a temp variable to traverse through this linked list, and at the same time I want to create a new node as well. Data. Then using a while loop, I can traverse through this list. Then during each and every step, I can check I just reached to the location or not. Right? I can just say temp dot next. So temp dot data is equals to the target location. Instead of location, I just using the word target. This make a sense, right? Temp dot data equals target. If this gives true, it means you came to the target location, right? Then can update first you can create the first link. First link means new node with the next node of the target location. I can say new node dot next equals temp dot next. In the now the temp pointer is pointed here. The target is found. Temp pointer is pointed into this node, right? Then the memory location or the reference of the next pointer of the target location is stored inside this, right? Then I can access to the next pointer or the reference of the next node by just taking the next value of the temp variable, right? Temp dot next means it gives the reference of this node. Then I can update this memory location with the memory address of the this node, right? As the first step. Then I can update the next pointer of the target location node. I can say temp dot next equals new node, right? Then I can return from the function. Else, I have to update the temp variable one after another to continue the traversal. Temp equals temp dot next, right? That's it for insert middle. It's very simple. My suggestion is to, in your end exam also, my suggestion is to first, if you want to implement a code for a data structure or whatever the thing, first you can draw a diagram, something like this, right? First, draw a diagram with clearly showing these steps. Then by just looking at the diagram, you can implement the code. It is very simple. right? This is the most effective way to implement this kind of algorithms. First, draw a diagram and show the correct order of these steps. Then by just looking at the diagram, you can implement the code, right? This is the simple operations for linked list. Initialize a linked list. You can initialize it with the constructor of the class. Then you can initialize a linked list with the constructor of the linked list class. You can initialize an empty uh, node with the constructor of the node class, right? Then you can insert front, insert back, or insert middle. You can implement the functions. Before inserting, you have to initialize an empty, or before you have to initialize a new node. You can use this constructor of the new node class, and you can distribute this data using the constructor. After that, you have to check whether the linked list is already empty or not. If it is empty, it means you can insert your new node as the very first node without any doubt. If it is not, uh, you have to follow the separate steps for separate function trees. For insert front, you can first you have to store the currently first node reference inside the temporary variable. Then you can update the next pointer of the new node, and you can assign the current node reference, current first node reference into the next pointer of the new node. Then you can update the head with the new node. Then if you want to insert the back, we have an additional step. You have to find out the last element, currently last element of the linked list. You can use this while loop, right? First, you can use this temporary variable, and you can assign, you can use, take the first object reference of the first element or first node using the head pointer. Then you can use a while loop to traverse through this linked list, and you can find out the last position. Then you can insert the new node as the last element of the linked list. Then if you want to insert the middle part, we have an additional step. First, you have to find out the location. First, you have to find out the location. Again, we can implement a while loop, and inside the while loop, I can check the data part one after another. I can check the data is equals to target or not. Once I find the target location, first I can create a link between the new node and the next node of the target position. Then I can update the target position pointer with the new node, and I can just return from the function. Then from your main method, uh, now I have just initialized an empty linked list. Then you can call these functions. List one dot insert front, sorry, insert front. You can pass a value here. List one dot insert back. You can pass a value here. Then if you want to insert at the middle position of the linked list, you can use insert mid function. Insert mid function. This time I need to pass two parameters. First, the data, and the second, the target. For this one, I can insert number 20 as the value, and the target location, let's say 5. Once I execute this program, First, it initialized an empty linked list. First, it's initialize an empty linked list, something like this. Then after, it insert the very first node with the value 5, and this head will be updated with the reference of the first node. This is null. Then insert back, it means the number 10 node will be inserted as the last element of the linked list, and the null pointer will be updated with the reference of the 10 node. Then if I execute this insert mid, so what happened here is, first it find out the location. What is my target location? It's 5, right? It 5 means I'm going to insert my new node, which is having the value 10 after 5 before 10. Then I have to update this with this as the first step, and this with this as the second step. That is what happened when I execute these functions separately one after another, right? That's it for linked list. It's very simple. If you draw a diagram, a clear diagram before implementing the code, right? I think that's enough for today. I will share this recording through your LMS as a YouTube video, so you can go through this again. Okay, I will share this code with you as a zip file in your LMS as well.